Alright, so in the last video we created the buffer handler file, which is going to be handling or buffer information for rendering primitives or objects to the screen. So in this video, what we'll do is we'll create the shader loader, which is going to load shader code from whatever path you specify. So opening up our Netbeans project, the first thing we're going to do is we're going to go to our handler package and create a new Java class, and we will call this class shader loader and hit finish on that. So within the shader loader class, it's just going to be one method which is going to read the code from the GLSL shader code from a particular file and return that as a string. So takes a file path. We currently are not returning any string yet, so that's why it's complaining. So we'll just temporarily put a return empty string there. So it should be okay. At the end of the method, it'll be taking in the proper variable that we're returning. So since this is loading from a file, we need to be doing some basic file I/O activities. So constructing a file from that file path, and you'll import java.io.file. And then we're going to use a buffered reader, and this is for optimization in the event that the file is very large. You want to buffer that reading. And we'll also be needing a separator, a file separator. Line separator, sorry, not file. I'll explain this in a moment. And finally, we'll need a string builder object where we'll hold the shader code. So we're going to do some tests. So if the file does not exist for some reason, we're going to fail really early. Print that as an error. Could not find shader file. And then exit 1. Right, so the file doesn't exist, we fail really early, and we terminate the entire program, which is what we should do, because if we can't load a shader file properly, then the other steps that are involved in getting the OpenGL primitive to render the screen, the objects to render the screen, are going to fail as well. So since we're dealing with buffered readers, we need to handle exceptions. So we'll open up our try block, and we'll catch an exception. We'll fill in that exception in a bit. So in here, we'll do reader is equal to new buffered reader, and we're going to wrap this in a new file reader. And we'll need to import the file reader. So here's where we'll do most of the work in loading the file. So we're going to need a temp string to temporarily hold the current line from the file. So we'll say while temp is equal to reader dot read line, while that is not equal to null, we're going to save that current line. So shader code dot append the temp string, and we need to separate the line. So here's where the line separator comes in. Depending on which platform you're on, the line separator may be different. So it's different on Windows, different on Linux. So that's why we got the line separator for whatever platform you're on. So append to that shader code, the separator. Yeah, append to that code, the separator. And after that, we'll say the reader dot close. So that closes the reader. Now, if anything weird was to happen while we're reading, an exception will be thrown, so we're gonna catch that and handle it. We'll see error reading. Why we couldn't read it, and the message, and again we'll exit. So if everything is fine, we'll modify our return statement to say return the string that we read, and that's all we need for our shader loader. The next class we're going to create is actually the shader handler class, and this class is going to do the shader handling for us. So it's going to create a shader. We're going to have a method to create a shader, a method to compile a shader, and finally a method to link the shader into our program. New JOGL class, and this is now shader handler. So we hit finish on that. So we're gonna have about 3 methods in this class. So the first method is going to create a shader, and when the shader is created, it returns integer reference to that shader. So for that reason, our return value is going to be int. So to create the shader, we're going to take the shader path, and we're going to take the type of shader we're creating, specified by a number, and then a reference to the current GL context. So it's complaining again because we're not returning anything yet. So I just say return 0, and we need to do the import for the GL4. So the first thing we're going to do is we're going to create the shader object. So this will just be a lot of OpenGL calls. So the shader is equal to GL dot GL create shader, and we'll see the type of shader we're creating. Now, if for some reason that was to fail, the shader value would have 0. So we do a test to see if it's equal to 0, and if it is, we fail early again. Creating shader. They're creating shader. System.exit 1. So as long as everything went fine and we got past that point, what we do next is copy the shader source code into the shader object. So we're gonna grab the shader code now. I will be using the same shader loader class we just created. Since it's a static call, we just specify the method load shader file and we pass the shader path to that. And then here's where we're gonna copy the code into the object. Specify the shader we're using, the number of strings we're going to be passing in. In this case, it's just 1. And for that reason, we'll create a new string object and we'll pass in the shader code. And then leave that one as null, which should be the offset, I think. Not too very familiar with the API. So the next step is compile the shader. And here we see JOGL compile shader. And we again need to verify that the shader was compiled. Well, this shader operation was done successfully. We need some place to hold our result, which returns the result as a ternary, and to get the compile status, get shader IV, and we're going to pass the shader there, and then the compile status. We already have the result, and the offset into that result is 0. Into that result object is 0. So then, let's check to see if that compiled successfully. So if the result is 0 is equal to GL4 underscore false, and OpenGL may have its own definition of false, so that's why we're not using the Java false. It might not be the same value. So if it's equal to false, we're going to print an error message. And we're going to say shader compilation failed, and we're going to display the shader path so you know which shader failed. Now if it failed, there will be some messages provided by OpenGL as to why it failed, so we need to get these messages. So say get log. So we're going to get log the shader compilation. So int log length. Because it's going to return the log into an array. So once again we call the GL get shader IV, and specify the shader that we want, which is the current shader. And what we're looking for this time is GL underscore get that log length. So what it's gonna do is, what we're gonna first do here is, in this method, is figure out how long the length of the log is. So it's gonna store that value within this log length parameter here, so we know how many bytes we need to reserve so that we can allocate the string properly. So if, as long as that log length at position 0, as long as it's greater than 0, then we know we have something in the log. So we need to create that amount of bytes to hold that information. So we'll create a new byte. We'll say log length 0. And now we're actually going to get the log. Get the shader info log, specify the shader, specify the log length, which is 0. And there's some other parameters here that you need to specify. We'll take an empty int array, and the offset into the array is going to be 0. And then we'll take the actual log that we set up, and the offset into that is going to be 0. And now finally, we print the shader log. And we'll construct a new string out of that set of bytes that we reserved. Right? And as long as all of that failed, we exit, because we're really in the error block still. Right. So terminate in the event of an error. And when we finish there, we're going to be returning shader. So this is how you would effectively create and return a shader. The interesting thing is actually creating the shader is pretty straightforward. Most of the lengthy bits of code involved checking to see if there are any errors, creating the shader and displaying them, which is really important, because if you have any errors in the shaders, you would like to get some feedback as to why it failed. So we have 2 more methods, and this class should be complete. So now we're gonna, after we would have compiled the shaders, we're now able to create a program. And creating a program typically involves compiling 1 or more shaders together. Well, at least 2. You'll need the vertex shader and the fragment shader. So we're going to take a list of shaders, and a reference to the current GL context. Again, it's complaining because we're not returning an int yet, so we like to just say return some value. So what we'll do is we'll get a program handle, gl.gl create program, one of the very few methods in OpenGL that does not have any parameters. So again, if the program handle is equal to 0, that means some error would have occurred. So you print that out. You see there is some error creating that program object. Fail early. And now we iterate over each shader you received and attach it to the program handle. So for each shader in the shader list, we're going to attach it. So program handle shader. Yeah. So we're going to look through each shader in the shader list and call the attach method on that to attach a shader. And then when we're finished, we're actually going to return the program handle. Alright, that's it for the create program method. The final method we're going to have is something to link the programs. The reason I'm not writing all this, or we're not doing all this in one huge method in this class, is because there are certain things you might need to do between these method calls to set up your data properly. So splitting it up across these three methods allows you to make other calls between these methods. So sometimes you may want to do stuff after creating the program, before linking the program, and so forth. So that's how we're doing things this way. To link the program, we'll need a reference to the program handle and a reference to the current GL context. So GL link program handle. That's all we're going to do. So the next thing is getting the link status to see if any errors occur. So in linking the program, there might have been errors. So the rest of this method is really just to check for that. It's important though. And data size 1. Get program and take the program handle and we're specifying the GL link status. Passing the status array, the offset being null. So we don't know what's going on with the link status, so we're going to check that status. So if in the status we get a value that's equal to GL underscore false, whatever they return, we're going to display a message. And this message will say failed to link shader program. And then again, we need to get the log to see what's happening. So we specify the log length, which is looking for an array. And bear in mind that these arrays that you see we passing, you have to understand that OpenGL is a C API, so you will have to adhere to that a little bit. So if you're wondering why we just don't pass the regular int, you need to understand that it's really making calls to C API, and C has certain rules. So the API is implemented a certain way, and it expects certain parameters in the Java. JOGL is a wrapper class for those native calls, so this is how things, they specify they need arrays and stuff, so this is how it's done. We pass the program handle, and we say again we want the link to that log. JOGL4, get the log length, then we're going to pass the log length we created and see an offset of 0. So if the log length value returned in position 0 is greater than 1, that means we actually have some stuff in the log. We again need to create some bytes to hold that information. Right, so we create the same amount of bytes as the log. Now we're gonna get the info log. So it is going to take the program handle and the log length, which is 0. Again, this parameter is just an empty int array. It's a parameter that you don't need right now. At a rate that we're not specifying, we say the offset is 0, and then we pass the log. And the offset of the log is 0, so we'll start writing data to the first position, and now we're going to print that out. Program log, and here we see a new string log. And keep in mind we're still in our error block, so if any error occurs, exit 1, and we exit. So this actually, for now, concludes the setting up of very basic template that you'll use to draw images, render objects onto the screen. Yeah, you still won't be seeing anything if you were to run this. That's because we haven't really made any calls to OpenGL to draw anything onto the screen. So in the next tutorial, what we're going to do is we're going to specify some vertex and color data. We're going to create two very simple shaders and compile and make them and do some rendering onto the screen.